Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at Enterprise DB. I will be your host today for our webinar. And today we are joined by Marc Linster, Senior Vice President of Product Development and Support, Bruce Momgen, co-creator of SQL, and we are here with Thom Brown, one of our sales engineers. And today, before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the questions panel. Along with that, if you have any suggestions for future webinars, please drop those also in our question box. We expect the presentation to last most of our time today, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards with any attendee whose question was not answered. Now, without further ado, here are Bruce, Marc, and Thom.
Thank you, Molly. Okay, so this is part of the Pulse of Postgres series, and so where we are in that series is we've started with what's new in Postgres 12. We went to how to install on Linux, etc. And then so today we're talking about JSON and JSONPATH in Postgres 12. And then in November, we will talk about programming the SQL way with common table expressions. Bruce is going to do that webinar and talk to us about CTEs. And then in November, we'll look at highly available Postgres installation using Kubernetes operators. Okay.
So Marc, what are we giving away today?
Today, hey, we're giving away Postgres socks again, and I think Bruce can show us what they look like.
Yep, there we go. Here's my demo portion of the exercise. There we go. Is that clear enough? The best I can do.
Yes.
And I don't actually.
So everybody's going to ask.
Very stylish.
You don't have a pair? Okay. Well, we will ship out these socks to everybody who's asking us a question and gives us a business address in the U.S. or in Europe that we can ship to. So let me just bring this back. For some reason, the screen has gone on mute. Okay. So let's just go back here. So as I said, as Molly said today, Thom's going to walk us through the through JSON and JSONPATH. Before we get there, just briefly, hey, I'll spend just a few minutes on who is EDB, EDB Postgres platform, and then we're going to dive into JSON, JSONB, and JSONPATH. Thom's going to give us a demo of how that works. We'll have time for Q&A, and then we'll just look at what's next in the Pulse of Postgres. So first, who is EDB? We are one of the leading companies providing support for the open source for open source Postgres. We've been around for 15 years. We've been recognized by Gartner and Forrester as a leader in this space. Over 4,000 customers today with several hundred employees worldwide, and we are one of the major PostgreSQL community supporters today. So when we look at the positioning that Gartner has given us and Postgres in the Gartner Magic Quadrant, it's really showing that that they see us as able to execute and have the completeness of vision that that database users need today. The reason why this is important is because Gartner has recognized that Postgres and Enterprise DB has the ability to execute for large enterprise applications, and that Postgres and EDB have the completeness of vision that is required to actually provide an enterprise level solution to the needs of customers who are looking for relational database management systems. Postgres and Enterprise DB has been in this Magic Quadrant since Gartner restarted it in 2013. And what is important to point out here is that in the 2018 Magic Quadrant, there is no other open source relational database present except for Postgres and Enterprise DB. Now, we're not just talking to Gartner, etc. In the 15 years that we've been in business, we've been able to convince a lot of customers, many of the Fortune 500 customers, lots of Global 2000 customers to use Postgres and Enterprise DB to meet their needs for relational database management solutions. Bruce and I are working with many of these customers, Thom the same way, and I can tell you that most of them are not using Postgres today for small departmental solutions. They're really using it for mission critical, really important applications. We're not just active on the commercial side of Postgres. We are, as I said before, one of the major supporters for PostgreSQL and the open source community. Here are all the people who are on our staff and are fully dedicated to working with the Postgres community and the PG admin community. So we have a significant investment on that side, not just on the commercial side where we work with lots of large customers and Gartner, but we are very, very invested in the open source way of working with Postgres and the surrounding ecosystems. So at this point, I'll turn it over to Thom, who's going to talk about Jsquery and JSON as it can be used in Postgres. Thom?
Thanks, Mark. So let me share my screen. Sorry, one moment.
Mark, every time I see those numbers of the number of companies we have, I can never remember the exact numbers. So the only way I could remember it was we're like 20% of the global 500, and we're 15% of the global 2000, and that is easier for me to remember than the actual all these numbers flying around. I'm like, all right, we're 20% here, 15% there, and that's easy for me to remember. It also shows we have a long way to go, right? I mean, so
we've come a long way in 15 years, and there is still a lot of room for improvement. But I think, as we've seen at the last Postgres Europe conference last week with over 560 attendees, that Postgres is widely successful. And when we look at the companies that were there, obviously, interest is across all industries and company sizes.
Yeah. You good to go,
yeah,
Thom?
Postgres has come a long way in that time. We certainly wouldn't be talking about Postgres JSON 10 years ago. So to be talking about this today shows how far Postgres has come in over these years. Okay, shall I get started? So just a quick overview of what we're talking about. So the two things in question, we're comparing functionality of Jsquery and SQL JSON. So these both provide a way to query and retrieve JSON data using expressions passed to a function or a specialized operator. So in Postgres, there's a huge array of different operators you can use to compare one value against another, and there's one specialized for JSON data types, and both Jsquery and SQL JSON use their own, and there's also functions that support these. But just to explain what these two things are, first of all, we have Jsquery. So originally we had JSON introduced as a data type in Postgres, but it was really just a text format, and they introduced JSONB a bit later, which is a binary representation of JSON. And what the difference with this is it allows it to take up less space. It got rid of duplicates, and later on it allowed indexing on JSON data. But then we wanted a way to query this data, because really you'd be checking against strings, treating the JSON data as a string, and it's not very a natural way to interact with this data. So an extension was created called Jsquery to help with this. This one was introduced in PostgreSQL 9.4. I think it's still available if you want to use this, even in the latest version of Postgres. You technically can. You can compile it, or it's possible that if you've got a package manager on Linux, for example, that it might package Jsquery with that as well, and you can just install it as an extension. This provides a way to query and index JSON data. And as I said, it's an external project. It's not available in core. So what I mean by that is it doesn't come with Postgres as standard. So it doesn't come with the community version. It doesn't come with EDB Postgres server. And it's also not officially supported. So the community don't support Jsquery because it's not part of the Postgres project. Postgres has a number of extensions, probably off the top of my head, maybe 20, 30 extensions, and Jsquery isn't one of them. So any one of those extensions would be supported. If there was an issue with it, you could go to the community and say this extension isn't working. With Jsquery, you can't. It's not a community project. So this one is primarily available on GitHub if you're installing it from source. And as I say, it's managed externally, but it was created by people who also work in the community.
Thom, so Jsquery and I guess SQL JSON, are they giving us languages that allow us to query JSON instead of being like operator based? Is that the difference?
Yeah, well, it's got its own internal query language, as it were. It allows you to access JSON data and index JSON data as well, but it isn't understood well by the planner. So the planner doesn't know about the data being queried. So you don't end up with a very efficient query plan because it's still the extension having to try and help access this data. But yeah, it has its own language. That's what we'll cover in the next few slides, is what this language looks like. So how you access the JSON data, and I'll go through some examples as well. And the SQL JSON also has a similar language, but it's not the same. And I'll go over what these look like in a moment. So yeah, that's Jsquery. SQL JSON. So this is the name of the functionality that's been introduced in PostgreSQL 12. So this also provides a way to query and index JSON data. It is built into Postgres. It's not an extension, so it's not even an official extension. It's part of Postgres server itself. And it's also standards compliant. So this is a feature that's come out of SQL standards. As I've left a note on here saying that they both operate on JSONB, which is binary represented JSON, and not plain JSON. So when you're creating your tables and you want to put JSON data in it, you'll need to use the JSONB data type. It's not the end of the world if you use just plain JSON. You could cast it, but that's quite inefficient, and it wouldn't really make sense to do that if you're designing it from scratch. So yeah, SQL JSON is the name of the feature being introduced in PostgreSQL 12. So also just to explain again, just to emphasize how you end up being able to use these features. So to install them for Jsquery, as I said, you'd have to install it from like a package manager if it happened to support it. It depends on which distro of Linux you're using, I guess. Or you would have to compile the extension from scratch. all the problems that can come with that, I guess, if it's not compiled correctly. Once you've compiled that, you would do it on your system. In order to use it, you would have to go into the database that you want to use Jsquery in, and then create the extension. So you've probably seen the command when you're running creating extensions in your databases, creates extension and then the extension name, and you'd have to do that for every database you want to use Jsquery in. Obviously, that doesn't work if you haven't compiled or installed it. And then once you've done that, you can go ahead and use the features that provides the operators and functions. But for SQL JSON, as I said, it's built into Postgres. If you've installed Postgres 12, there's no extra steps to do. It's part of Postgres. You don't have to create an extension. It's not an extension. And the data types and the functions and the operators are just available from the off.
And Thom, Postgres 12.
So far?
Yeah, Postgres 12 was available when? When did Postgres 12 get ready?
Postgres 12 is very recent. It's in the last month. Bruce, do you happen to have an idea of what date that was?
I am pulling that date up now. I was actually traveling when it was released, so I should remember that. It looks like it's October 3rd of this year, so it would have been 20 days ago.
Yeah.
Okay.
I knew it was very recent. It took me by surprise when I saw the announcement. It's like, oh wow, it's available already. But yeah, Postgres 12 is very new. Sorry, were there any other questions before we continue? No? Okay, so what I'm going to cover now are just a comparison of the functionality of Jsquery and SQL JSON. Before I do, I'm just going to cover some of the SQL JSON functions that are the primary functions that you use with SQL JSON. So just to start off, I'm actually going to skip ahead to this middle line, JSONPAth query. This is the one that I suspect most people will end up using. So that's probably the one to look at first, but I'll cover all the functions here. So we've got JSONPAth exists. So this matches true if it's matched, false if it's unmatched, or if it's targeting a missing value, it will return null. I've also left a column here showing you an operator, so you don't have to use the function. You could use the @ symbol and question mark, and then on the left side you'd have the data you're querying, and on the right side you would have the expression that you want to use with that. Then we've got JSONPAth match. It also has its own operator, which is @. So that's the same as the previous one, but only the first item, first result item is tested. So the thing I mentioned first was JSONPAth query. This doesn't actually have its own operator, but this returns JSON data resulting from an expression, and I'll demonstrate that later. Then we have JSONPAth query array, also doesn't have an operator. So this does the same as path query, but it has the results in an array. And then JSONPAth query first, it's the same, but it only returns the first value. The one we're going to be focusing on today, though, is JSONPAth query. So I've just made a few tables that show you the equivalent functionality between Jsquery and SQL JSON. I've actually put JSONPAth here. So just to explain, JSONPAth is the data type used for SQL JSON expressions. So that when you're passing an expression to a function, you would cast it to a data type of JSONPAth. So that's a data type. That's
the same thing we do with TS query with text search, right?
Yeah, it's pretty much the same thing. So it's not something you would ever, well, I guess you may find a way to use it in a table. I can't think of practical use, but you would use it in a query essentially. There may be instances where you don't have to specify that your expressions are JSON path expressions, but I would always be explicit about it so that it doesn't ever get confused. But I'll demonstrate how we use the JSON path data type. So here we have two columns, Jsquery and JSON path. So these are variables that are available in the two feature sets. So the first one's a $. It's the same for Jsquery and JSON path. This accesses the whole JSON document. Got a full stop or period, which is the accessor. So this would be accessing the contents of $. Don't worry, I'll have some examples of how we use this. And then asterisk that returns all values at the current level. JSON path. So far the language has been the same for between Jsquery and JSON path, but JSON path also has double asterisk, which is all values at all levels. So that effectively goes through the whole JSON document and not just the top level or the current level if you've been accessing it to a lower level. I guess in case you're worried about working out how you fit these together, I'd probably just take in the fact that some of these features are available in SQL JSON and not Jsquery, and a couple are available in Jsquery and not JSON path. So the description is probably the main part here. I wouldn't worry too much about the specific syntax.
I had a question, Thom. Did the SQL Standard Committee use Jsquery as a basis for their syntax, or just lined up that way, or?
I think it lined up that way. I can't be 100% sure. I don't know if this is there is a standard defined, so it may have come out of that standard. I'm not 100% sure on that.
Right.
There is a lot of overlap though, and I don't know if it is. I don't think it is a result of it. I think a lot of this is maybe because they saw the way this language was going in early drafts, but yeah, I'm not 100% sure on that.
Interesting. Makes sense. And both of these, the Jsquery and the JSONPath contribution to core Postgres, were done by the Russians. Is that right?
Yeah, that's right. Yeah, it's Alexander Korotkov, Theodore Sigiev, and Oleg Bartonov.
Yeah, they've been working on this for like forever, and they even did a lot of the JSONB work as well. So it's it's really
they've been quite a lot involved in the whole JSONB, and this sort of thing.
I coincidentally did wear my Russian Postgres shirt, so it was kind of funny with the little Russian hat on it. See that? It's kind of funny. Yeah. But yeah, they've done an amazing job here, I think.
Yeah, they've been community members a long time, and they like you mentioned Jsquery earlier, and I'm pretty sure they were heavily involved in that side as well.
Oh yeah, they've been around, I think, longer than I have, which is a long time.
And me.
Yeah, Oleg, I think, goes back to 94, and I'm 96. But yeah, it's kind of amazing some of the technology that the Russians have developed, and this is just a great example of that. I mean, it's just amazing stuff that takes Postgres in brand new directions, and I think Postgres has really led the way for JSON in general across the industry, and this is just sort of a verification of that, I think, and we're just really matching the syntax the SQL Standard Committee chose.
Yeah, definitely, and there's more in the works as well. I mean, this isn't the end. Postgres 13, I suspect, will have a whole new extra set of features that complement this or enhance this. So yeah, this is just the beginning. But this is a great start anyway, because we couldn't do any of this before.
Yeah, I mean, at the time we added full text search to Postgres in the 2000s, everyone's like, wow, you got an SQL engine that has full text search in it? Like, that's kind of weird, but very innovative. And this is another example, JSON in an SQL database, same kind of idea.
Yeah, I just wonder what they're going to come up with next.
Yeah, hold your seat, hold on to your seats.
But yeah, we've got a lot of feature functionality available on this. I mean, this looks like a small table. There's actually quite a bit more I'm going to show you. But yeah, this is just the variables. I mean, so I mentioned these first four ones. There's also hash n. The equivalent in JSONPath is where it differs. So you wouldn't use hash n. Actually, what do you call that in the US?
Pound sign.
Pound sign. N. That's it. Sorry, pound
Hash
sign
is
means
fine.
something else to us. So pound sign n. The equivalent in JSONPath would be dollar and then in square brackets, then the number. So it's the nth value of an array starting at 0. So n you substitute with the part of the array that you want to access. Something in JSONPath that wasn't available in JSONQuery. It's the same as the above, but it gets a slice of the array. So rather than defining one element of the array, you can say it gets a slice of the array where it starts and where it ends. You can't do that in JSQuery.
Yeah, and it makes sense because if you're going to add that start end capability, that syntax in JSQuery wouldn't work. So it makes sense that they added the brackets. So now you can put 1 in there, or you can put 2 in there.
Yeah, I think it would look a bit hacky if they tried to tack that onto the existing syntax. So yeah,
that's a great idea.
And I don't think they're going to bother trying now. So yeah, there's something you can do in JSQuery that isn't built into JSONPath is the pound sign that accesses all array elements. There is an alternative way to do that in JSONPath that I can explain separately, but it's just a different way of doing it. It doesn't have a symbol that represents the exact same thing. And the same with the percentage symbol accesses all object keys. There is also a way to do that in JSONPath. It's just not represented by a symbol. So there's also various methods. Most of these aren't available in JSQuery. We've got plus and minus signs, which are unary operators. These just operate on a sequence, and we've got plus and minus, which are binary. These provide addition and subtractions, and asterisk, / multiplication, division. So these can operate on JSON data in JSONPath. You can't do that in JSQuery. There's no equivalent. And as you can imagine, these seem like fairly important operators to have. I don't know why JSQuery never had them. Maybe there's some way to do it, but it's not available in JSQuery. One thing that is available is to check the type of data in JSON. In JSQuery, you use the keyword is and then the type, and then JSONPath just returns uses a function. It looks like a function, so type open bracket close bracket does the same thing. Getting the size of the array, so JSQuery and JSONPath can both do this. They just do it different ways. JSONPath uses a function name to achieve that. And then I've listed 5 more functions that are available in JSONPath where there's no equivalent in JSQuery. So double ceiling, floor, abs, and key value. So these are maths operations that can be performed on JSON data. And also key value returns the object represented as a sequence of key value and ID fields. So you can see there's already on the methods side, most of them aren't available in JSQuery. So that's if those are important to you, then it's obviously a no-brainer, and you could have never used JSQuery to start off with. Then we've got various operators. I won't go through them all in detail, but you can see in some cases they're very similar, like this first line. They're all the same except equality operator is double equals in JSONPath, and the rest are the same. So that's the same when you query JSQuery and JSONPath expressions. So addition and subtraction. So that's available at the SQL level, or you could use the operators mentioned previously. Actually, I've done a typo here. These are actually contains in. So, apology, these descriptions aren't correct. So that's my bad. But so rather than go and find them, so I can tell you these at and greater than and less than and at are contains and contained in, or contained by. So you can't do that in JSONPath natively, but you can do that at the SQL level by comparing two sets of data with the SQL level operators. And ampersand and ampersand is overlap. That's also available at the SQL level. And or not operators, there's just different names for them. And we've also got exists, which is the same. You can't do starts with or find whether a string starts with a certain set of text in Jsquery, but you can in JSONPath. And you can do perform regular expressions in JSONPath, whereas you can't in Jsquery. So yeah, apologies for the descriptions being wrong here. I've obviously updated 2 columns and didn't do the last one. Yeah, I think the regular expression things would be a deal breaker for me, because I use regular expressions to access data, very specific sets of data all the time. So that's pretty important, and JSONPath provides that. There's also some special values. These are just true, false, and null. These are the same in Jsquery and JSONPath, but JSONPath has one which is unknown, and that can query whether the result was unknown. There's no equivalent in Jsquery. Just to note that the null value isn't the same as SQL null. I think if it doesn't mean unknown. I think the is unknown is closer to the SQL null. I think that's when it doesn't match any data and you get a null result. Okay, so I'm just going to show you some examples of how we compare these two. So let's start with Jsquery. If my screen starts responding, okay. Okay, just to double check, my screen's visible, is it not?
Yep. Mm-hmm.
Okay, so the first one will select some elements from an array which are equal to 1. So we end up with just that one result. So this is a very simple example, but the purpose of this is to show how you do the same thing between Jsquery and SQL JSON. So here I'm just setting up some JSON data, which is really just an array in JSON, and we're just going to query this. So in order to query data in Jsquery, we use the double tilde operator, and then we provide the actual Jsquery query in a string. So let's show that, and I'm going to fill in the query now. So this is just a string that's cast as the type Jsquery. So for this, we're just accessing an element and then opening a filter, and we want an element that is equal to 1. Remember, that's a single equals for this because we're using Jsquery, and then we get the result. I mean, it's kind of obvious what the result is doing, because we only want the one that is equal to 1, and we get 1 back. But it's meant to be a kind of a straightforward example. I'll try and try and get these both on the screen at the same time. This is Postgres 12. So this is where we can use SQL JSON. So we want to do the equivalent here, but now we don't have an operator to use for JSONPATH query. So we would type out the function. And as the first parameter, we want the data with query. And then we cast that as JSONB. And then we pass in our expression. So, oh yeah, this is JSONPATH. So that's where the JSONPATH comes in. I think you can get away without providing that data type, but
yeah, I was going to ask about that. I was actually just going to look to see what the function signatures are for those. Because usually it'll cast them, but I haven't actually tested this yet.
Yeah, I don't actually know how many signatures there are for this one.
There's actually only one signature. So,
oh, okay.
Yeah, it
so
takes a JSONB and then a JSONB path, and then it has and then it looks like something. It looks like it takes a JSONB at the end, and then it has a default. Boy, it's pretty long.
Yeah, I mean, they're optional parameters, aren't they?
Well, you know, it's kind of hard to tell from the signature. If you just do \df JSONB _path _query, you'll see what the signature is. And
oh, okay.
I'm kind of lost. Oh, I know what it was. Yeah, you're right. It's because it says the third parameter says vars JSONB, and then it has the word default, and the default is an empty JSONB array, which makes sense because you're not passing anything. And then there's another parameter called silent, and that defaults to false. So there's 4 parameters. The first 2 are required. The second 2 are optional.
Yeah. So there's the other parameters I've intentionally kept out of these examples because we're just doing straightforward comparison. So yeah, there's a lot more that these functions can do, and there's a lot more control over them that you can specify, which it shows in the documentation. But yeah, I'm going to keep these 2 pretty simple. But yeah, these first 2 are mandatory parameters, and there's some optional ones that we aren't going to bother with today. So we want the equivalent in JSONPATH. So rather than use the hash, we have $ and in brackets star to access all the elements, and then we do our filter expression. So we want an element which is represented by equals 1. And this is where I run it and find I've got a typo somewhere. Let me double check before I run it. Oh, it worked. Okay. So the key thing to note here is the result type. So this is another part where it varies. I could have overcomplicated the comparison by saying sometimes you get a different result type. So here we get an array containing just the element in Jsquery, and in JSONPATH we get the scalar value that's returned by it. So they're not directly equivalent. You can make them equivalent, obviously, using a bit more code, but the functionality is effectively the same. But obviously, if you wanted this one an array, you could modify it so it would result in an array, and this one you can make into a scalar by modifying that one as well. But yeah, the main bit here is just to see how the language compares. So you can see that you can't run exactly the same thing and get the same result because these aren't compatible. So another example, sorry, I'm just consulting my list here to make sure I'm remembering correctly. So here we'll have an array and we'll check for all elements that are greater than 1 and less than 5. So this one is also going to be really straightforward. So we just got an array. JSONB data. Remember, it's got to be JSONB and not just JSON. And here we are going to provide an expression, a Jsquery expression. So I'm using at instead of tilde. I think I can't quite remember why I need those different here. I'll check that in a sec, because I wanted these to be functionally equivalent. So I'll find out why I had to do that in a moment. It's not too important because we don't want to use Jsquery, but I can find an explanation. So we want elements that are, so this is the query section. This is where we want elements that are greater than 1 and also less than 5. Have I typed that correctly? I think so. So yeah, array, we just want the elements that are greater than 1 and less than 5. As it happens, they're all they will meet that criteria. Oh, okay. So this particular query returns true or false. So this one is checking that all elements match the criteria. Okay, so that's the difference. This one is performing a test, and this one's retrieving data. So the equivalent of this one in JSONPath, where's my window? Here it is. Let's try and get these both on the screen at the same time. So again, we get the array. And here we can do an exists operator, which is at question mark. So we don't need a function for this one because we've got an operator that can help us. And then we want the JSONPath expression. And right, so we want all elements. Oops. And we want to query it where the element is greater than 1. And we don't use the keyword and, we use double ampersand. And then element less than 5. And we also get true. So those, you can see how those return the same result, and they're doing effectively the same thing.
And you didn't need to cast the array into JSONB?
No, it figured that out implicitly from the operator being used. I would advise, I mean, this is bad practice, I would advise always adding that in. That's a good point. Just for the sake of not being ambiguous, if you end up with an ambiguous situation where you're using an operator that happens to be an operator for something else, that can work on other data types, you could probably end up with an error. So yeah, it's good practice to specify JSONB. I should have done that in my first example as well.
It's really the fact you've cast the second argument at JSONPath, Marc, that assumes then there's only one operator that has JSONPath as a second argument for the operator.
Yeah.
And \do will show you that. If you just do \do ampersand question mark, you'll see there's only one.
Ampersand question mark. I'm glad you remember this because I don't.
No, not @ but ampersand question, I think, was it? What were you using there?
Oh, yeah, okay.
Yeah, right, there you go.
Yeah, so yeah, you're right. So left argument, right argument. So what Bruce has just mentioned, oh, it won't let me highlight. You can see where my cursor is.
There's only one, right? So it's you almost don't need anything. I guess you don't even need the second one because there's only one matching there.
Yeah. So what Bruce is pointing out is it just so happens that for this query there's only one possible left and right data types that can be used with this. So it just assumes that they're in the data type specified, but that hasn't been specified, but matches the operator. So yeah, there could be a case like with some of the other operators, like the double at symbol. There's also JSONB, JSONPATH, but yeah, we can see there's one where there's text on the left and text on the right, or a TS query on the right. So yeah, with that one, you would have to specify at least the JSONPATH side, or at least one of the sides.
Either side. Yeah.
But yeah, it's good practice to just always specify, just to know exactly what result you're going to get. Yeah, that's a good point. That's worth mentioning. So I had one more example, and I'm just going to see if I've created the table beforehand. Yes, I have. Okay. Have I done it in both? If I haven't, I can quickly do that. Select star from books. No, okay. Okay. Sorry, one moment. I'm going to call it data JSONB. Sorry, I've got a table, example table set up, so I don't need to pass a long string into the query, so it's easier to manage. But if I quickly type this in, author Charles Dickens, and then we have one book, A Tale of Two Cities. And then one more book with the author William Shakespeare, and book, whoops, but then quotes. Want it to be valid JSON, otherwise it's going to tell me off. Let's get these brackets right. I'm bound to have typed something wrong. Give it a go. Yeah, I've typed something wrong. Sorry, one moment. Let me move this out of the way so I can see. Tale of Two Cities. Have I balanced everything? Tell you what, I have this on a blog entry. It's available on Postgres Rocks and my own blog, but let's just nick it from here. Okay. No. Sorry, one moment. I'm just going to reconnect. Okay. So if I paste that query in, right now, I don't know what I typed wrong, but we now have our example data. So we've got example data in both databases. It's just a table called books. It has one column, which is of type JSONB, and it's got two JSON objects in with key values of book and author. So for this one, we just want books by William Shakespeare. So here we would just select the column data from books, but we are going to be accessing the data Jsquery, and now we want to specify what we want from it. So we want top level items, then we'll specify the query, and we want an element, an object with the element called the key of author with the value William Shakespeare. Oh, I'm going to type William Shakespeare. No, I typed something wrong. Oh, it's meant to be double colon. So here I've just selected the data column from books, but then performed a JS query operation on it, where we want objects from that JSON data where it has an author key with the value of William Shakespeare, and it's just returned that data. So you can see it didn't return the Charles Dickens Tale of Two Cities information. And then the equivalent in SQL JSON. I mean, this isn't really showcasing SQL JSON as such. It's more a case of seeing how they compare in usage. And as it happens, we can't use an operator on this one. I wonder if they're going to introduce one in future. There may be a technical reason why it hasn't been introduced, like it conflicts with something else, or it causes other issues. But for now, we can use functions. It works exactly how we want it to work. So we're using JSONPATH query here. We pass in the data column from the books table. We don't have to specify the data type because Postgres knows the data type because it's specified in the table. But as I said, if we're providing strings to a function or constants, we want to be, I was going to put Jsquery then, JSONPATH. We want to be specific about the data types we're using. So here we want to select everything and then filter it. So our filter would be where we have an author value. So it's an object with the author value of William Shakespeare, and again we've used double equals because that's the equality operator in JSONPATH. And oh, I've done something wrong there. Have I typed William Shakespeare wrong? I have.
I think it's the capitalization. Is that right?
I think it's the E. Yeah, no, I just left the E off the end.
Oh.
I almost did it the first time. I don't know why I'm resistant to adding E onto Shakespeare. But we get exactly the same result, though, as you can see. So yeah, you can see this one's Jsquery and this one's JSONPATH. So you could do all of this before in Jsquery, but it's now built in and there's a lot more functionality available. You can technically also use Jsquery with PostgreSQL 12. It wouldn't really make sense to do that because you're not adding anything, and you could technically mix them up. It wouldn't make sense to do that though, because we've got JSONPATH. It does everything we need to do. It makes Jsquery effectively redundant. But it just shows where this has come from. There was an external project that was trying to provide this functionality, and it was awkward to sort of get installed, and it wasn't officially supported. That in itself is a problem because if there's an issue with it, you don't know if it's going to get fixed in a timely manner, and it wasn't standards compliant. Now we've got a standards compliant set of features that are built into Postgres, not even an extension. It does all the same stuff that Jsquery did and more, and that's going to be improved in future releases as well. So I hope that shows that the abilities Postgres has for querying JSON data. I mean, these examples were very simple ones. This is just to show the language comparison and the equivalence. It's not really a demonstration of all functionality it can do. We may talk about that in future, and then we can go over everything, all the sorts of queries you can run on it. But for now, this is just the difference between Jsquery and JSONPATH syntax.
So I have a question, Thom.
Yeah, sure.
I guess I'm backing up, but the thing that I kept hearing as I went through this is it feels like we're recreating the SQL expression syntax that you typically see in like a where clause, right? And you're creating your own SQL JSON language. So when would you? I guess my question is when would you use the normal SQL expression syntax that you'd see in a where clause, or even in the target list where you can do things like comparisons and return booleans and so forth? And then when would you use this JSON language basically?
Yeah, that's a good question actually. Well, one thing you could do when you've got a result, like let's find a previous example. All right, well, let me do it. We had a result which returned a scalar value. So you wanted to compare that scalar value to another value in the database, but it isn't in your JSON data. You can't do that from within a JSON expression because you're providing a constant value. Even though it's an expression, it's considered a constant, and you can't refer to other columns in that. So you would want to get the data out of JSON, and then at the SQL level, you would want to compare it. So if I give you just a quick example.
But why wouldn't you do everything at the SQL level? That's what I'm trying to understand.
Because you can't drill down into JSON data at the SQL level. You query it as a string, but it doesn't understand the JSON structure.
Okay.
It doesn't know what key values are, etc.
And as I understand, the other thing I think they're planning on working on that I've heard Oleg talk about with Jsquery, and I assume it's the same here, is the ability for the JSON expression engine to actually walk through the index and do comparisons at the index level, so it doesn't have to necessarily go to the heap to instantiate each row. Like you could take, I want all the JSON values greater than 5, and you could walk through the JSON index to pull those out. Is that something you've heard about?
Yeah, that would be index, and it would perform an index-only scan effectively. I mean, you can index this data already. I don't know the limitations as to whether it requires accessing the heap if it hasn't been, like if you vacuumed it recently, whether you can just use index-only queries. I haven't tried that myself, but it's, yeah, I'm surprised that it's not already possible.
Well, it's going to require, you're going to need optimizer changes, because as I understand it right now, when you say, I want a row that has this key and this key, for example, there is logic inside the index scan to say, give me all the rows that have this first key and then subtract out the ones that don't have the second key. So there's already some logic in the index scanning of JSON-B that allows you to kind of filter before you actually have to look at the heap row. And as I understand it, the real, like, in performance value of this is to take that even farther, to be able to do pretty complex things inside of index expressions that you normally, not index expressions, but during index scans that you normally wouldn't be able to do with a normal value, because of course it's because the JSON value is multi-key.
Yeah,
you can effectively chew it up, while you're in the index, which has some real interesting performance benefits.
Yeah, I'm not surprised that they're working on some sophisticated indexing solutions. I actually haven't followed the indexing side of things. I do know there's indexing functionality in this to speed up these queries, but maybe that just helps find the rows that it needs to get the data from rather than scanning all of them. and it doesn't let you just do an index-only scan. But yeah, there's always a long list of things they're trying to add into it. I haven't checked what the current list is and what the priorities are, but yeah, that doesn't surprise me, and that would definitely improve performance for a huge number of use cases, I can imagine, especially with massive data sets. Yeah, no, that's interesting to hear. But yeah, I hadn't followed that too closely.
Okay, Tom, we should probably see if we can still take one or two questions from the audience. I'm not sure, Molly, if we got questions.
Yes, we have actually, we got a lot of questions rolling. We'll answer just one or two with the time that we have left. So to start, the first question that came in is there a JSON table function to transform JSON data into a relational representation?
That rings a bell. I think that's due to come out in a future release. I could be wrong. I remember reading about it, and I don't think it made it into 12. I could be wrong. JSON table. No, there is actually in the documentation. There's a section called, if I can find it, SQL conformance, and then unsupported features. JSON table. There's JSON table functionality listed in the unsupported features. So yeah, I think that's something that's currently not supported by Postgres.
Okay. And then another question that we had is there a way to use SQL/JSON on versions of Postgres prior to version 12?
No, there isn't. This was never available as an external extension, like even experimental. This is all in core. The closest thing you've got is Jsquery. So if you needed similar functionality before 12, you would have to depend on Jsquery. But then when you get to version 12, it would be in your own interest to convert that functionality into the native SQL JSON functionality. So yeah, you can't use it on previous versions. You'd have to. The only alternative I can think of is Jsquery.
Okay, wonderful. So for anyone who has posted a question in our questions box today, now is the time. If you live in the US, please send us your address so we can send you a pair of socks. We want you to have a pair of our socks, especially with winter coming up. We're very excited for that. I do apologize. This is all the time that we do have for questions. For all of the questions that haven't been answered today, they will be posted on postgresrocks.com, which will be linked in our follow-up email. Thank you all for joining us today for our webinar, JSON and JSONPATH in Postgres 12. Thank you, Bruce, Marc, and Thom for being here. We will be sharing this recording along with the slides with you as soon as possible, and I hope you all have a great rest of your day.
Thanks, everyone.